What's up, math minions? Pre-cal peeps. We're going to now continue talking about our functions. Again, or yesterday, today, one of those days, the last lesson was about finding, just evaluating functions, including evaluating piecewise functions. That was kind of new. So again, make sure you go and watch the video that I took during the class period on that if you haven't already. Of course, you should have in order to do the assignment. But let's go ahead and get your notes out. And again, I'm going to encourage you guys to take notes. If you're not taking notes by now, so something's wrong. So let's talk about zeros of a function today. All right. The zeros of a function are the values for x which make the whole function equal 0. The important thing is that is not the same as doing f of 0. F of 0 means we get to substitute a 0 for the x. Finding the zeros of a function are finding the x's that make the whole thing equal 0. Okay, that's the major difference, and that's the difference here. Here, 0 is an input. Here, 0 is the output. Okay, so we want inputs that make the output become 0. Again, if we think of a function as an input-output relationship, you gotta have something that goes in and something that comes out, then that's the difference here. So for this one, over here, this function, find if f of x is equal to 2x plus 1, I want to find the zeros, meaning I want the roots is another word that we use mathematically, but I want to find the x's that make the whole thing equal 0. All I need to do is set it equal to 0. Again, it says f of x equals 0, so this f of x is going to be 0. So we're going to say 2x plus 1 equals 0, and now we're going to solve like we know how to because we're pretty good at solving, right? We're going to subtract 1 from both sides, and 2x equals -1, and then we'll divide by 2, and that is our solution. So that is x equals -1/2. And as always, we can test it, right? We can check our answers. That's the beautiful thing about these questions here is math. You can always check your answer. So if we let me get this to show up just a second here. Where did it go? We can check our answers. Let me just close it and try it again. Okay, so in these, sorry for this, but we can check our answers, and the way we're going to do it is we're going to substitute the 1/2. So if I can do 2 times substituting the -1/2 in there plus 1, it should equal 0. Okay, and that's what we want. We want the whole function to equal 0. So that's what our solution is. Now we can write it as x equals -1/2, but I may ask you to write it as a coordinate. Okay, and if I write it as a coordinate, this is an input because it's the x, and the output is a 0. Okay, that's our x, y, that's our input output. Okay, again, the difference from yesterday's was you had to input something to figure out the output, and so you wrote it as an order pair input output. Okay, all right, let's do the next one now. Now we have a fraction. Oh no, we hate fractions, but that's okay. We're still going to do the same thing. We want to set it equal to 0. Okay, that means to set the function equal to 0 and solve. All right, so we're going to set this equal to 0 and solve it. When does this whole function equal 0? Okay, so now we got to talk about some solving issues with this. Okay, again, we're trying to get to x, which means we're going to undo everything. Okay, the first thing I'm going to undo is this dividing by 2 because the dividing by 2 is happening to all of this, right? I can't get to the -5 yet. I can't get to the times 3 yet. I'm going to undo this dividing by 2 because it's happening to everything. Okay, here's the nice part. 0 times 2 is still 0. So really, when you have a fraction, the only part that we really have to worry about is this top part, because 0 divided by anything is still just 0. Okay, and then here's the math that proves that. I didn't have to worry about that times 2 on the bottom, or sorry, the dividing by 2 down there, because when I multiplied by 2, it just turned into 0 anyway, because it was equal to 0, okay? And then now we're back to doing something like we did up here, right? We do a plus 5, and that gives us 3x equals 5. Then we divide by 3. Okay, don't worry about dividing it. All I really need is a fraction that's reduced. If you don't want to, don't give me a decimal on this. Just leave it as 5/3, okay? So on this one right here, we're going to say x equals 5/3. And again, if I ask you for a coordinate, you'll put it in as 5/3, comma, 0, because that's the input that makes this output 0. And as always, you could check it, right? If I substitute a 5/3 into this and divide it by 2, 3 times 5/3 is just going to be a 5, and 5 minus 5 is 0. 0 divided by 2 is still 0. Okay. Again, the important thing is you can check your answers, but what are we asking for? We want the zeros, and the zeros are the x's that make the whole thing equal 0. Okay. Inputs that make the output become 0. All right. All right, now let's talk about piecewise functions, because that was kind of new in the previous lesson, how piecewise functions work. Okay, remember, we get to use this piece for x's that are greater than or equal to 1, in this case, greater than or equal to 1. We get to use this piece if our x's are less than 1. Okay? In order to find the zeros, remember, this is all one function. We use this piece for this condition. We use this piece for this condition. It's possible that there's an x that makes this turn into 0, and there's possible there's an x that makes this turn into 0. So we could be looking at having multiple solutions. So the way that we do this is, the first thing we need to do is set each piece equal to 0. Okay, that's our first job. So I'm going to write 2x plus 1 equals 0, and I'm going to do x squared minus 3 equals 0. Okay, and then we're going to solve. We're going to solve each piece. Okay, so let's solve this one. Again, that should look familiar. We just did that. All right, minus 1, 2x equals negative 1. Then divide by 2, So x equals negative 1/2. Okay. Now that I have a solution for this one, I need to ask the question, does the solution meet the condition? Okay, you have to check your conditions. Conditions for each piece. Okay, if this solution meets the condition, I get to keep it. Okay, so look at this condition. In order for me to use this piece, x has to be greater than or equal to 1. Is this x that I'm saying is a solution, is a 0, would this x, if this was the x value I'm trying to input, would it even get put into this piece? No. Okay, it does not meet the condition. So I get to say, no, I don't get to keep that answer. This piece has no zeros. Because negative 1/2 would not be used in this piece. Okay, if I tried to input negative 1/2, I would look at the conditions, and negative 1/2 would not be put into this piece. So using negative 1/2 would never make this turn into 0. Okay, because when I try to put in negative 1/2, it's not greater than or equal to 1, so it wouldn't go into this one. It would actually go into this one, and I don't know what the zeros on this one are yet. I just know that negative 1/2 doesn't work in this piece. Okay, that's what you have to do. So you set each piece equal to 0, you solve, then you check the conditions for each piece to see if you keep that 0, you keep that solution for x. Okay, let's do the next one. Okay, let's talk about it. It's got a square in it. Well, first thing, as always, we're going to add 3. We're going to try to get x by itself. Okay, how do I get rid of a square? I want x by itself. I don't want x squared. I want just x. Hopefully you said you need to take the square root. Okay, now here's the catch. We're doing just a purely mathematical situation. So when we take a square root, we need to put down plus or minus. Okay, so that means there are two solutions here. Positive square root of 3 and negative square root of 3. Okay, there are two solutions. X equals positive square root of 3. I'll just put square root of 3. And x equals negative square root of 3. Okay, again, I need to check my conditions. I have two solutions here for this one, but do they both meet the condition? The condition for this piece is that x has to be less than 1. Okay, this one doesn't fit. The only solution that fits is this one right here. Okay, only negative square root of 3 is a 0, because positive square root of 3 would not be used in this piece. Okay, I hope that makes sense to you guys. Then when it comes to piecewise functions, each piece has a condition. Each piece has a condition. So when we try to find the zeros, we need to check, does that x meet the condition for that piece? If it does, we keep it. This is the only one that we got to keep. If it doesn't meet the condition, we toss it. It's not a 0. So this one only has one solution, and its solution, its 0, is negative square root of 3. Or we could write it as negative square root of 3, comma 0. Because if I tried to put negative 1/2 in, negative 1/2 would not go into this piece. Even though it makes this piece 0, it would actually go into this piece, and that's not going to make it a 0. Negative 1/2 squared is going to be positive 1/4 minus 3. Well, that's not going to be 0. All right. When I try to put in positive square root of 3, positive square root of 3 is greater than 1. Positive square root of 3 is greater than 1. It would not go into this piece. It would go into this one, and that's not going to turn that one into 0. Okay, so there's only one solution on these. So that's kind of the new thing. Again, you're just going to finding zeros, you just set it equal to 0 and solve. If it's a piecewise function, you set each piece, but then you have the extra step of checking the condition. All right, that's what the assignment's going to be about. See you tomorrow.